Courtney Payne, Associate Editor at ASHRAE Journal. Thank you for joining us for today's webinar, part of the High Performance Building Supplier Webinar Series. The series provides information of interest to HPB readers and others about products and technology of interest to industry professionals. ASHRAE does not review supplier webinar presentations. The following presentation has been prepared by Automated Logic on the subject Achieving Healthy Buildings with Building Automation. Today's speakers from Automated Logic are Joe Tossing and Ken Gilbert. Joe Tossing is the Southeast Regional Sales Manager for Automated Logic, supporting authorized dealers in the application of ALC products, software, and services. Joe has over 20 years of experience supporting building automation systems in vertical markets, such as commercial buildings and higher education, as well as critical process environments, including data centers, healthcare, semiconductor, and critical fluid flow applications. Ken Gilbert is a regional technical consultant for Automated Logic, supporting design engineers and consultants in the Atlanta area. Ken brings significant industry experience to Automated Logic, having served with the Train Company and Honeywell International in a variety of sales, engineering, and consultative roles. Ken graduated from the Georgia Institute of Technology with a Bachelor of Science degree in Industrial Management. Ken and his family live in the Atlanta area. Joe, the microphone is all yours.
Hey, thank you, Courtney. We appreciate the opportunity to present this information. As Courtney mentioned, I'm Joe Tossing. I'm the Southeast Regional Sales Manager for Automated Logic. With me is Ken Gilbert, our Factory Technical Consultant for the Southeast region. We appreciate your interest in this topic area. We've got about 45 minutes of content we'd like to share, and then we're going to leave some time for some questions at the end of this presentation. This does, if you go through the whole webinar, you do get a continuing education credit. You can jot down alcwebinars@carrier.com. You'll receive an email with a link. There's a quick knowledge online check, and then you can access your certificate for the credit. We do want to put forth a little bit of a disclaimer. This presentation's been prepared from multiple source materials. It really represents the viewpoints, perspectives, and opinions of myself and Ken. It's not intended to replace the need for the application of sound engineering practices and judgment. We've got a number of links here that we would encourage you to reference for further information related to pathogens, COVID, and the topic area that we're going to discuss is really evolving, and it's being updated in real time. So please be sure to check the ASHRAE website and other technical resources for latest information. What we're hoping to cover today is what is a healthy building, the foundational elements of healthy buildings, and then how building automation can be applied to realize healthy buildings. And basically, you know, a healthy building supports physical, psychological, social health, and well-being of people in buildings and the built environment. That's a holistic perspective. It's much broader in scope than our traditional focus on energy efficiency and maintaining comfort and indoor air quality. It includes perspectives that take into account the perceptions and preferences of occupants, as well as the social impact of the built environment. Our industry's really significantly advanced the study of building health, and we found that maintaining ideal indoor environments is not only good for the health of the building occupants, it's also pretty good for the bottom line. In 2015, there was a groundbreaking study by the Chan School of Public Health. It's referred to as the Cog Effect Study or the Cognitive Effect Study. And this research found that, you know, we spend 90% of our time indoors. The buildings we live and work in have a direct and measurable effect on human health. The study found that by increasing ventilation, adopting green building enhancements, cognitive function increased dramatically. People scored better in crisis response, information usage, strategy scoring. Sick building symptoms were greatly reduced. People were sleeping better. There's a significant aggregate reduction in greenhouse gas emissions. Green certified buildings were compared to conventional commercial buildings, and in total, they saw reductions in energy costs, reduction of CO2 emissions, the economic benefit of reductions in missed work, absenteeism, and reduced healthcare costs. And in fact, the researchers found that the value of productivity increased almost $6,500 per person per year. And as we work our way through this current pandemic and adapt to a new normal, the condition of the built environment and the willingness of people to return to work is going to be impacted by how well we address health and wellness in our buildings. Our building automation systems are an important technology platform to help us get there. And really would like to, talk a little bit about, how we minimize risk in the workplace as we start thinking about getting back. This is a fairly common pyramid that OSHA and the industrial hygiene industries used as a framework to address risk in the workplace. And this framework can be applied to a sensible approach to reopening or considering how to reopen our buildings. The first layer of defense requires committed enforcement of work-from-home policies. Once the main workforce is approved for reentry into a building, however, strengthening administrative controls becomes a crucial step in protecting occupant health. Administrative controls include promoting employee education, enforcing social distancing, kind of de-densifying the work areas, reducing food preparation areas, other potential transmission hotspots, but really adding a lot of hand sanitation stations, enforcing a rigorous program of preventative disinfection, and then alongside some of these administrative controls, and the focus of our discussion is really the engineering controls that can be brought about in our buildings and in our spaces. And central to that effort is an emphasis on improving ventilation, air quality, humidity, thermal health. ASHRAE has concluded that a prerequisite to any strategy is a well-designed, installed, commissioned, and maintained HVAC system. And to that, we'd like to advocate that the authors of the COG effect study, they've continued to advance the science behind healthy buildings, and they've suggested that there's 9 core foundations that support building health. If we consider best practices being recommended around each of these elements, and we incorporate these into our designs, and also have an eye on these as we retrofit and make changes to our existing buildings, the result's going to be indoor environments that are safe, comfortable, and contribute to the productivity of the occupants. These foundational elements that we're going to focus on are ventilation today, our ventilation, air quality, thermal health or temperature, humidity, and then filtration. We have a companion presentation that'll be about 3-4 weeks from now. Dave Rothgeb, also with Automated Logic, is going to touch on the other elements of the 9 foundations. But for today, we were going to limit our discussion to just these topic areas. And really, one thing that I think everybody's kind of getting to the point, the building automation systems today really have evolved to become information technology platforms. On the technology side, there's been an explosion in advanced visualizations and reporting. We're using more cloud-based services, edge computing, IoT, a whole host of communication and network capabilities being leveraged to bring in large data sets into the conversation. And that really supports the artificial intelligence and machine learning that we're starting to see and leverage. And this really benefits the occupant experience, improves productivity, enhances comfort and health. And, it's really underpinned by a lot of changes in the delivery mechanisms. We're seeing more and more strategic alliances, private-public health partnerships, a lot of movement towards a master system integrator discussion, and really the healthy buildings of today, they're better realized, easier to control when all these attributes are brought together and presented to the operator through a single pane of glass. So the master system integrator movement is really taking on a lot of steam in the current environment. So the digital transformation is strong with us. we do see a lot of desired attributes in a building automation system. Operators and users are asking for 100% web-based or cloud-based systems. They certainly want a lot of capability for individualized occupant experience. We're seeing a request for a lot of thin client environments, unlimited and simple licensing models, certainly rich visualizations, support for multiple devices to be able to access the systems, but additionally, a strong emphasis on analytics and the ability to do advanced programming. Your automation system today provides greater trending reporting, supports a lot of flexible database architectures, allows us to develop a whole host of innovative control sequences, demand limiting, fault detection, diagnostics, and certainly advanced integrations, enterprise to enterprise to support business process systems. We do a lot more equipment level integrations, smart building integrations down to the individual devices, fire, smoke, and then open application programming integrations for development of innovative add-ons and integration to islands of automation that used to be difficult, if not impossible, to do in the past. So with the modern BAS system, you really have a complete holistic capability to provide command and control of all the electromechanical systems, fire, smoke, security, these intuitive user interfaces, all these analytics and visualization tools. Despite all the integrations that we can do, really, typical architecture hasn't changed too much. We still have an IP level network bus across the building. We generally will have system and building level controllers that communicate to sub-networks of field level controllers, and it's the ability to pull all those together and create a cohesive, holistic user experience that's credible to operate that mechanical system that really adds value to the owner and allow us to not only provide energy efficient buildings, but also healthy and sustainable indoor environments. So today, we do want to focus on temperature, humidity, filtration, air quality, and ventilation, and how we can use our automation system to support these healthy foundations. And again, this comes from the Chan School. This is inspired by the Chan School of Public Health at Harvard and the work that Joseph Allen and his team has put together. Next slide, Ken.
Yep. So we're going to take a little bit and talk about central command and control. And really, as we're going through this presentation, I want you to be thinking about your BAS system and how in the past the BAS system was traditionally used to control temperature, and now we've moved to monitoring an entire building and looking at the equipment. And we look at an entire system and then how each component works in that system and how we can optimize for energy efficiency, the implementation of these individual pieces of equipment in an entire system. So for instance, instead of operating a chiller plant just on an occupied, unoccupied schedule, you start looking at aggregating cool requests, or the same situation would apply for a boiler plant. You would start looking at heat requests before you actually turn a boiler on. When you get into fan systems, you can start looking at using trim and respond logic to do things like static pressure reset or discharge air temperature reset. But the real goal is the BAS has the flexibility and the capability to implement these different strategies. And then in today's environment, what we're seeing with the pandemic, and there are requirements to change maybe how a system operates, making sure your BAS system has the capability to implement these changes and move forward. So we're going to take a little bit and talk about temperature and humidity considerations. So the big thing is from ASHRAE, there are no real limits on temperature and humidity as it pertains to limiting the spread of infectious disease. but there are some studies that show maintaining relative humidity levels between 40 and 60% can limit that transmission. But generally speaking, from ASHRAE 62.1, the recommendation is to have a maximum indoor dew point of 60 degrees if the outdoor dew point is above 60. So maintaining that indoor environment at dew point of 60 degrees is important. And then monitoring those humidity levels is important to prevent condensation and mold within the facility. In applications where ventilation has been significantly increased, you need to look at maybe adjusting those set points in the zones to account for what's going on with the additional outside air that's being brought in, and make sure that as you adjust those set points, you maintain the occupants being satisfied with those higher set points. And what you can do is you can basically reset the supply air temperature at your air handling units based on what's going on with the zones. So in a VAV system, if the zone's not requiring as much air, the damper's going to be closed. Maybe look at resetting that discharge air temperature up a little bit. And doing this will allow you to handle a little bit more outside air because the system will be able to handle that additional load.
I asked Ken to put this slide in here because I think it's a pretty cool visualization and represents some of the capability of some BAS systems. This psychometric chart actually allows us to take real-time data from a fan system. We've got a couple of data points in the green shaded area. Discharge air temperature, return air temperature, mixed air temperature, and not suggesting that you have this in every automation system, but I think it's a pretty cool representation of how you can plot the actual conditions of your system against a psychometric chart to get a visualization of where you're at relative to design and relative to the set points, and be an indicator of how your system's operating. But I thought it was a neat graphic, and I wanted to throw that in there and show it. It does speak to that temperature and humidity discussion. Moving on to filtration. We all know how filters work, and certainly they capture the dust, smoke, pollen, particulate matter, and pathogens if they are there. As we work through our current guidance, we're being encouraged to increase our MERV rating to 13, and really would, as you consider making changes to the system, you want to make sure that you don't just arbitrarily change your filter. There certainly will be impacts on fan performance as the pressure drops increase. We know that in some geographies, increasing to a higher MERV rating, the filters are going to load up. Very important that facility operators engage their building engineers, their design engineers, and refer to the latest guidance. Work with your test and balance contractors, your commissioning agents, to make sure that you understand the impacts on your fan systems, duct static, the coils, as you change filtration. Sometimes you won't have enough supply fan to move air through these filter racks, and you really want to be careful as you make changes to the filtration profile in your building. But there are some enhancements that you can make. You want to go to that? Yeah.
Yep.
So any changes in the filtration, you may have to adjust your controls, fan speed, airflow set points, differential pressure switches. If those are not enabled, be sure to get those in there. Increases in filter effectiveness, you might have to change those filters out more frequently, and One thing to keep in mind also, any systems that don't have economizers generally can't be used to increase your ventilation. So you're going to have to take a look at what other areas you have available to increase outside air.
Also, Joe, I want to add some other things to consider from a BAS control perspective. In the past, to monitor filter status has been done a couple different ways. One way is to monitor runtime and change the filters after the fan or the air handling unit has been running for X hours. The more common method is to use an actual differential pressure switch as a filter. And this is a switch that has an adjustment that's at the filter itself, and whenever that filter differential pressure drop hits the set point that's on the switch, then it sends an alarm to the BAS to say, hey, change the filter. One of the things you might want to consider is instead of using an actual differential pressure switch, is go ahead and put in a differential pressure transducer or sensor and set it up so that it will actually alarm based on the actual pressure drop across the filter, so that whenever you hit that loaded point, an alarm is sent to the BAS to tell the operator to go ahead and change the filters. This will also allow you to, as you put in MERV 13, deeper MERV 13 type filters than what's there, it just gives you a little tighter control and another insight into how the system is operating and what you can do to operate the system more efficiently and provide a more healthy building.
Yeah, thanks, Ken. And that brings us to the indoor air quality discussion. Certainly a lot more attention now. The current guidance around indoor air quality, and all of these factors are very closely related: temperature, humidity, outside air conditions, your flow rates. This is an engineering community. Everybody knows how the dependencies are so interrelated. But the indoor air quality, as a subset of the indoor environmental quality, there's a lot of great filtration capabilities, but a lot of good sensors as well, CO2, VOC. As you start looking at indoor air quality, we know a couple of things. If you can stay within 70 to 74 degrees Fahrenheit, 40 to 60% relative humidity, CO2 levels not more than a couple hundred ppm greater than outdoor ambient, you're doing fairly well. But there's a lot of sensors coming into the market, and there's a lot of emerging technologies that can be improved to clean the air, and we leave it up to the design engineers and the facilities to evaluate those technologies and determine if they're appropriate for their building and their application. But the current guidance around ventilation is really kind of a mixed bag right now. I would encourage everybody to review the Taylor Engineering white paper associated with COVID-19. There's some great information there, and really deep dive into the outside air and the dilution discussion that's happening in our industry right now. To the extent that you can increase outside air, some folks are advocating up to 100% and shutting off our return air dampers and going 100% outside air. That's certainly going to come at an energy penalty. But one thing that we are seeing is there's a lot of buildings that have been operating in part load conditions, and really would want to take a second here and advocate that before you do anything and make any changes in a building, we encourage you to really do a complete retro commissioning and really understand how your buildings are operating. Do that flush of the hydronic systems. Work with your engineer of record and your commissioning agent, your test and balance contractor, and your building automation contractor, and try to do a point-to-point across the entire HVAC systems and make sure that those systems are operating correctly, that belts are balanced, things are lubricated, everything's working correctly. Look at your dampers, look at your valves, look at your points of monitoring and control, and do a little bit of functional performance testing before you start making some changes. Certainly a lot of value in documenting and recording a baseline before you make any changes. And then, we would encourage you, don't make any changes until you really understand the impact of those changes. And this is where you really need to lean on the design engineer. And this is where a building automation system with the ability to return reports, trend logs, perhaps the ability to do time-lapse analysis of how all these electromechanical systems work. This is where the value of the BAS system really comes into play. But around this ventilation discussion, you can go ahead.
Just to add to what Joe was saying, having a very robust BAS system will allow you to provide the reports that Joe was talking about and use those to establish your baseline before you start making changes, so that you have a real understanding of what's going on in the building. And then a couple things to keep in mind when you make changes to particularly outside air ventilation, and you increase the amount of outside air coming in, is you need to make sure that the system that you have, whether they're packaged rooftops or applied built-up air handling units, that the system has the capability of handling that additional outdoor load without sacrificing indoor temperature and humidity to keep the occupant satisfied. So a couple things that have been recommended for ventilation that you can implement with a BAS system. We're seeing some requirements to do a pre- and post-occupancy purge before the building is actually occupied. 3 hours prior, you bring in outside air and flush the building, and then you turn around and do the same thing after you unoccupy the building at the end of the day. And once again, this is going to be a function of the system and what it's capable of doing, and I just want to come back to ensuring that you have a BAS system that gives you this flexibility to do this and implement these type of changes into the system.
Thank you. Again, evaluating the overall capacity of your system, you certainly want to verify proper operation of all your economizer dampers and dampers. Certainly your design was taken into account, locations of outside air intakes and exhaust ducts. You want to make sure that you're not recirculating exhaust air. You can advance to the next.
And one other item of consideration when you are bringing in more outside air and when you're doing these purge cycles is you need to keep in mind pressurizing the building and make sure you implement strategies that won't over pressurize the building. So just another aspect, you need to be monitoring building pressure and maintaining proper building pressure as the building is being occupied and used.
Particularly in healthcare facilities, the building automation system will help you maintain the negative pressure environments for the patient rooms. The automation system generally will allow you to have point of use monitors that indicate the pressure relationship between patient rooms, anterooms, and common corridor areas. We frequently will aggregate all of those room conditions and provide visualization tools at, say, the nurse's station or other central locations to indicate the room pressure status. We do see an interest in 100% exhaust of patient rooms that are considered COVID rooms, and we certainly do increase outside air changes from 2 to 6. But there are some specialized environments in the healthcare setting And really, one thing that, some sources are advocating 100% outside air, and there is a great document that ASHRAE put together on building readiness. It's available on the resources page of the ASHRAE website. If the design team determines that ventilation is going to be increased, there are some strategies that are documented in that readiness guide on how you can increase ventilation such that the maximum dampers are dynamically limited, and how that will be deployed is certainly variable based on what points of monitoring and control you have available, what kind of automation system you have in that space. But we definitely recommend that you take a look at that. We can go to the next. So some of the mechanical system considerations, important points before you make any changes. Carefully monitor your indoor temperature and humidity levels. You can report on these. Generally, most automation systems give you the ability to send detailed reports on an alarm event to email recipients, pagers. Be sure to check the coil freeze protection, and that's one of the things that we would encourage you to check out with a commissioning and functional performance test. Do those measurements, make sure that as you increase loads that you're also increasing your freeze protection. Any changes to outside air intake without a careful analysis of the dependencies of the electromechanical system is not recommended. Make sure that you go in eyes wide open.
So some general HVAC adjustments, and once again, these are adjustments that you want to be able to make through your BAS system. Maybe you want to adjust the min and max ventilation airflow rates in the VAV terminals. Maybe you want to adjust the outside air minimum flow to match the unit design ventilation airflow, or even increase the ventilation airflow rates if necessary. Being able to disable the economizer switchover, or even raise the temperature at which the economizer is enabled. Adjust your dehumidification set points, and we already talked about this. Maybe look at changing your filter DP switches to actual filter DPs that you can monitor. And then if the facility is only partially occupied, considering adjusting set points and schedules for the unoccupied areas. One thing that I do want to point out is you need to be careful how much you relax those set points for the unoccupied areas, because you still want to keep the building under some control so that you don't have issues with mold and mildew and things like that.
Thanks, Ken. And I guess we just can't re-stress enough the value of recommissioning the entire system. Certainly if it's been shut down or it's been in part load conditions, certainly want to check your air filters, cleanliness, proper installation, consult with your design team and your operating engineers to see if you can increase the filtration banks. If there's not a filter status, consider putting one in so that you can be alarmed and notified when that filter loads up. And you certainly want to inspect the moving components, any of the electromechanical systems that are sustaining our indoor environments. Let's take a good, healthy look over all of that equipment, and certainly consult and engage with your consulting engineer who designed the system if you can, and then check all your ductwork for leaks and evaluate the need for cleaning, or even consider putting in the air cleaning. Some of this emerging technology, certainly we see ultraviolet light being installed for coils, and you're seeing a lot of interest now in bipolar ionization and other types of emerging technologies to clean air. With the automation system, we can generally enable, disable, and measure the intensity of those systems. There's a lot of sensors coming into the marketplace that help us measure the performance and the efficacy of these technologies. Any adjustments made to increase your outside air volume, consider the impact on your cooling and heating loads. Make sure that if you increase outside air and you're looking at heavy, high temperatures, high humidity in some environments, you may not have the load capacity in the chiller plant to maintain comfortable indoor temperature with increased outside air volumes. A lot of our systems were designed for energy efficiency and not necessarily providing the increased levels of ventilation that some are advocating. So just be aware of that. Certainly want to validate everything before you move forward. And then if any of the energy recovery wheels are disabled, consider that also on the impact of your systems. So important to, can't stress that enough. But again, I would refer you to the ASHRAE resources on building readiness for additional guidance.
And just to add on to the discussion that Joe had with energy recovery units, I have been involved with looking at buildings that have energy recovery units, and the owners have turned the wheels off, or they haven't maintained the wheels and the wheels aren't working properly. And I just want to stress to everyone, when you have those type of wheels, the system was designed for those wheels to reduce some of the load that would be on the chiller plant or the boiler plant. So you need to really consider what's going on if those wheels aren't being used and what impact that's having on the system.
And so any changes that we're being asked to make, we do see a nominal energy penalty, and the increased energy consumption, it can be offset by making sure that everything is operating correctly and as designed. Certainly recommissioning has a great value. And there's, all types of things that we see overlooked in a lot of automation systems, scheduling, setback control, set point resets, adding lighting and demand limiting. All of those can have no impact on ventilation, and they can all contribute to offsetting any increase in energy consumption that's brought about by increases. One thing that a lot of folks are interested in is how to pay for some of this, and we would like to point your attention to the 2020 CARES Act. This legislation, and certainly we're not accountants, we would encourage you to talk to your accountants, but this is the Coronavirus Aid, Relief, and Economic Security Act, and it changes the deductibility of capital improvements so that you can deduct those in the year that you do them instead of depreciate over a 39-year period. So this may be of benefit to some clients, and I understand it does allow you to go back to, it's retroactive to January of 2018. So certainly consult with your accounting professionals to understand the tax implications, but the 2020 CARES Act does provide some relief for implementing changes to the mechanical plant in the buildings. So it is something that you might want to evaluate. To learn more about that, hit the, you back up real quick?
I sure can.
Yeah, sorry about that. There's a Home Treasury Gov Fed response, so certainly want to get that on your radar. And then, thank you. We've got a lot of resources available to us in the industry, and we encourage everybody to check ASHRAE on a regular basis for any updates to their position on the coronavirus or any of these discussions about indoor air quality. As temperature control contractors, building automation professionals, we implement the systems that the engineering community designs, and we certainly want to follow best practice and take into account the emerging science behind this very important topic area. To that point, we look to ASHRAE, we look to WHO, we look to CDC, OSHA, EPA. Taylor Engineering has great information, great white paper. I encourage everybody to take a look at that. If anyone needs us to send that to you, you can shoot us a note to the ALC training at webinars, and we'll get you this list of online resources. And so, we wanted to keep it very, very short, kind of a 10,000-foot level on how, the healthy buildings, support this holistic concept that's been emerging around the physical, psychological, social health, and well-being of people in the built environment. Introduce you or reacquaint you with the 9 foundations that's advocated by the Chan School of Public Health, and then just speak to briefly how automation systems can really help support and help deliver and realize these 9 foundations. So we really appreciate your attention. I see we're a couple of minutes early, and we'd like to open it up for any questions if there are any.
And before we do that, Joe, I also want to point out, using your BAS system to create some visualizations for the occupants, and consider having screens at the entrances or foyers, or even to conference rooms that show information that's in the BAS that say, hey, this building is healthy, and provides information on what the temperature and humidity is in the building or in the space, and that it is within guidelines, and kind of give you a healthy building index, if you will, to let you know that the building is good. And that helps create some comfort level with the occupants that are in the building, knowing that it is being taken care of.
That's a good point, and I appreciate that. Now, I did want to mention we do have a companion presentation that'll be presented in about 3 or 4 weeks that my colleague Dave Rothgeb and Justin Mazzadri with Automated Logic, and they will talk about some of these visualization tools and some of these healthy building metrics that we're seeing in the industry.
So, Joe, here's our first question. Are there any new control strategies to compensate for the energy penalty with the disabling of many installed pre-COVID-19 strategies?
So we're seeing some control routines. So if we look at pre-COVID, December, January, a year ago as baseline, and now we're being asked to increase outside air. There are some control strategies that will allow you to bring in the minimum amount of outside air to satisfy those conditions, and link that to the chilled water position. And then as you bring in your outside air, and say the chilled water valve is at 90%, if your chilled water valve is less than 90% open, we can start tracking and allowing more outside air to come in. But it's really the balance between comfort, temperature, and humidity control, and the volume of outside air. So from a control strategy, if you can ideate it, we can implement it. If you can think about it, hopefully you've got an automation system that gives you the points of monitoring and control to try out some of these control sequences. I know in our case we have the ability to visualize and create a virtual environment where you can change your set points and you can change these conditions and actually see what happens in the space to understand the impact of any strategies that you're trying to implement.
All right. To help with energy efficiency, do you see any problems with water-to-water runaround in lieu of heat wheels? I can take this one. So that's really going to be dependent on, is the heat wheel a total wheel or just a sensible only wheel? If it's a sensible only wheel, then using a water-to-water runaround loop should be fine. If the heat wheel is a total energy wheel, where you're taking some of the latent energy out, a runaround loop will not provide that capability. Let's see here. We can take that one offline. You mentioned your systems can track UV efficiencies. Do you have any data on the efficacy of bipolar ionization versus UVC on coronavirus kill rates?
So the UV efficiencies, the manufacturers publish the life, so many thousands of hours of intensity, and then the intensity degrades over time. So we can certainly track runtime. We can certainly track if we have the ability to vary the rectifier, we're able to vary the power supply to the UV, but we do not have a lot of data. There's still emerging data on the efficacy of the bipolar ionization versus UVC. So we're seeing UVC in different applications. We see it at the 7 feet and above in occupied spaces. We certainly see it in the ducting around the coils, and then we're seeing the bipolar being installed in the ductwork and dispersed out into the space. But if you refer to the manufacturer's information, there's a lot of good information that the manufacturers publish, but there's not the volume of peer-reviewed studies on the efficacy of some of these that we could point to.
The next question is, do you have the ability to remote test actuated life safety dampers? I'm going to say the short answer to that is I would not recommend that because it is a life safety issue. I would keep the life safety dampers like smoke dampers and fire smoke dampers, being able to remote test those. I would keep that capability in the fire alarm system. Are there any cases nowadays when you still have to sacrifice efficiency to get precise control? No. If you have precise control, that should actually help you towards maintaining efficiency. The sacrifice on efficiency is going to be related to increasing the load through additional outside air. Your thoughts on the ASHRAE recommendations to turn off demand control ventilation to increase ventilation for COVID? We are not COVID experts. We would direct these types of questions to your ASHRAE recommendations and to even local code officials, and let that be their discretion on whether to leave demand control ventilation on or to turn it off.
Yeah, there's going to be an energy penalty if you close up. Demand control ventilation brings in just the minimum amount of outside air into a space, and there's certainly going to be a penalty if you increase outside air, particularly in warm and humid environments. While there is an energy penalty, I would say, what's the harm? Again, the jury's out on how much and all these ventilation rates, but again, a quality architected BAS system is going to allow you to trend it and at least have an idea of what the impact of that increased ventilation is.
So Joe, who makes the psychic chart graphic?
That's an automated logic.
Yeah, that was created by the automated logic graphics team. Along with better filtration, are you incorporating ionization bars or UV lights to help minimize airborne viruses? So once again, this is going to be up to the design engineer.
Right.
I will say, generally speaking, we are seeing more people incorporate ionization type filtration and or UV lights with the hopes of minimizing airborne viruses. How do you validate outdoor air ventilation rates and balance with equipment capacity? So the really short answer to that is, particularly in a VAV type system, look at how the VAV boxes are operating as you increase those outdoor air ventilation rates. You can also look at how the coils are operating as you increase those outdoor air ventilation rates. As Joe mentioned, if your coil valves are at 90% open, that means you don't have too much additional capacity in the system to add that additional load. So, but it really is going to come back to using test and balance, using a consulting specifying engineer to help you as a building owner determine where that balance is.
And hopefully you've got the trend reports that you can take a look at it. I'd always prefer looking at the actual operating characteristics of the building, in addition to how it was designed, but we all know the dependencies in these systems, and there's so many attributes, or so many impacts. If you can run good trend logs over an extended period of time, that's really going to get you a better viewpoint, and it's really how the system is architected.
Why should the CO2 system be disabled? I assume in this case here, the question is around the disabling of demand control ventilation. Once again, this is not something that we are advocating or recommending. There is just some anecdotal information that is being suggested by ASHRAE and others that you need to bring more outside air in this pandemic environment.
One way to do that is to disable the demand control ventilation.
Will commissioning before and after making the changes help? Yes. And the reason being is when you commission the system before you make any changes, you've established a baseline of how your building and systems are operating. And then when you make the changes, you can commission and confirm that A, that the changes are in place, and that B, the building is operating per the changes that you wanted to implement. And then you can see the impact those changes have on how your building operates, both from an energy efficiency standpoint, as well as looking at things like environmental temperature, humidity, CO2 levels, and things that are happening to the environment inside the building. That one we can answer offline. Can we add camera-based applications to limit occupancy in some areas like cafeteria, reception, inside elevators? So I would like to take just a minute here. The whole subject of, we call it people counting, occupancy measurement, is an emerging technology right now. People are using things like cameras. We are also seeing systems that implement looking at the number of devices that have connected to the wireless network, so things like cell phones and laptops, and using that to kind of extract an occupancy count. And yes, those things can be used and can be implemented to say, hey, we're at maximum occupancy, you need to wait. And once again, this goes back to some of the visualizations that I was talking about. So in this case here, like in a cafeteria, you might have a screen outside the cafeteria that says, hey, the cafeteria area is healthy, it's good, it has an occupancy count of X, and as long as you're below the maximum occupancy, you can enter, and if it's above or at the max, then you need to wait until that changes. Let's see here. How do you monitor or track the energy impact of the COVID-19 changes to the building sequences? So the primary way to do that is through electrical meters. In some cases, with BAS systems, when you've got applied systems with chillers. Some of that information you can extract through the BAS and look at the amp draw and what's going on there. But the simplest way is to use sub-electrical meters to monitor those systems, or even an electrical meter at the main panel to see what the energy use is. The key to this, though, is you need to establish a baseline before you make the changes, and then after you make the changes, you can see what the energy impact is.
Yeah, and then make sure that as you look back at, this is really where your trend reports can be very helpful as you look back and look at the consumption last year, try and normalize that data to outside air conditions, and then as you make these changes, you should be able to quantify the impact of the sequence changes.
What is the acceptable positive pressure amount in office and residential buildings? Generally speaking, when I'm working with buildings and engineers, we try to maintain a positive pressure in the building of 0.01 inches. We have a long one here. What are some of the integration strategies where BAS would collect useful information from other systems to reduce COVID risk? i.e. using lighting occupancy sensors or CO2 sensors to track building occupants and adjust airflow. So this goes back to what I was talking about just a minute ago. Yes, we do have the capability of integrating into other systems like lighting control systems and using the occupancy that they determine. We have a building down in West Palm Beach that we call CIB building, the Center for Intelligent Buildings. And we actually have wayfinding capability in that building where we're monitoring and tracking people within the building to know where they are and what is going on with occupancy. And then using that information even to adjust how we're setting schedules. And when I say that, if over a period of time we find that people aren't occupying a certain part of the building, we'll start relaxing the set points in that area until we start seeing an increase in the occupancy. Yeah, there are many strategies that can be implemented where you integrate with other systems for the BAS to make some informed decisions to operate more efficiently.
Yeah, we're seeing some really innovative ideas being kicked around about how to not only impact the HVAC plants, but also how the BAS system and the security platforms can be used to enforce some of the administrative controls. Every facility is going to be a little bit different, but in food service, having a mask counter to dispense individual masks for the workers as they come in and out of their shifts. We're seeing, interest in solenoid valve status switches that tell us when faucets are being used for hand washing and the frequency of those hand wash events relative to door status. There's a lot of analytics that can be derived from the automation system if we have the points of monitoring and control. So some really innovative ideas in how to implement and enforce administrative controls around dispensing sanitization, dispensing masks, ensuring that people are following the social distancing recommendations and requirements.
Next question, what is the filter efficiency recommended in the air handling units? Have you considered implementing the amount of filter stages or adding filter stages? So yes, ASHRAE generally recommends MERV 13 filters, and yes, there is some information in ASHRAE where they discuss adding pre-filters in the situation where maybe you can't get a MERV 13 final filter to fit in the existing rack. Maybe you have the capability of adding a pre-filter to that to increase the filtration.
I think we've got time maybe for one more, Ken.
All right. I understand that following ASHRAE recommendations will improve conditions to reduce potential for COVID-19, but how can you assure a tenant that the virus is not present in their environment?
that you really can't. I mean, unless you put in something to measure specifically for a virus, but you can certainly communicate the health posture of the building. And, there's going to be some risk in any endeavor. And if you take a thoughtful approach to, implement a layered defense strategy, work from home, administrative controls, substitution, engineering controls. From what I've seen, my personal opinion is, the indoor mask administrative controls, and then the communication of that health posture in the space, the healthy building metrics that can be communicated on a regular, ongoing basis for the occupants will make them much more comfortable to come back to the work or to their built environment. Do you have anything?
No, I think that's good. So we're at the top of the hour. I know there are still several questions to answer, and we will answer those individually. We'll reach out to you via email to answer those questions.
But yeah, we'd really like to thank ASHRAE for the opportunity to, put this information out there and have a conversation. We really appreciate everybody's attention and being with us for this webinar. If you'd like additional information, feel free to shoot Ken or I an email or a note. We'd love to link in with you, and we look forward to supporting the discussion around healthy buildings and how you can utilize your building automation system to get there. Thank you very much. This ends our presentation. We hope everybody has a healthy day and a healthy balance of the year.
Thanks, everybody.
Thank you.